So we are in section 4.1. What is probability? Well, probability is a numerical measure between 0 and 1, or 0% and 100% if you're looking at percents, that describes the likelihood that an event will occur. So look at this line here. Right in the middle, it's going to be 0.5 or 50%. The more you go to the left, the less likely it becomes until you get to a probability of 0, which means it's an impossible event. We're going to take a look at that through the notes as we get to it. Here's the middle again, 50% or 0.5. As you go to the right, it gets more likely to occur until you get to 100% or 1, which is definite. It definitely will occur. So the notation that we use, the P stands for probability, capital P. So the probability of A is the probability that event A will occur. So probabilities are assigned using intuition, relative frequency, or equally likely outcomes. Intuition uses past experience, judgment, or opinion to estimate the likelihood of an event occurring, which we're not going to use in this course. Relative frequency, the probability of an event equals F divided by N, where F is the frequency of the event and N is the sample size. So for example, in a group of 100 people, 10 are left-handed. So let event A equal left-handed. Suppose a person is selected at random from a group of 100 people. Then the probability of A, the probability that they're left-handed, is going to be the number of left-handed people divided by the total number, which is going to equal 10 divided by 100, or 0.10 as a decimal, or 10% as a percent. The law of large numbers. In the long run, as the sample size increases, the relative frequencies get closer and closer to the theoretical probability value. An example of this would be, for example, tossing a coin, and what's the probability that you come up heads, okay? The first time you might not come up with a head, or you might, but the more, if it's a fair coin, the more you increase, the more experiments that you do, the more tosses you make of the fair coin, if you will, the closer and closer the theoretical, or the closer and closer the relative frequencies will get to the theoretical probability value. In other words, you'll see it wobble up and down as you perform each experiment, but it's going to get smaller and smaller and approach 0.5 if it's a fair coin, or 50%. It should be, in the long run, half heads and half tails. Equally likely outcomes. The probability of an event equals the number of favorable outcomes divided by the total number of outcomes. So for example, let's say you draw a card from a standard deck of playing cards, excluding jokers. So in other words, you have 52 cards, you have 4 suits, hearts, spades, clubs, and diamonds, and you have 13 cards in each suit. We are excluding jokers. So the probability that on a draw from a standard deck of playing cards, you get the king of hearts, that's 1 out of the 52, 1 over 52. A statistical experiment. Any random activity that results in a definite outcome, like roll of a fair die. A simple event, one of the outcomes of a statistical experiment. So for example, staying with dice, which I'm doing for this entire explanation here, you roll an even number on the die. The event is a collection of one or more outcomes of a statistical experiment. So for example, you roll either a 2, a 4, or a 6. And then the sample space would be the set of all simple events. So if you're looking at rolling a die, you can either roll a 1, 2, 3, 4, 5, or 6. And they use set notation for the sample space S. So you have the parentheses around, not parentheses, the braces around it. This is important. The sum of all the probabilities of all of the simple events in a sample space has to equal 1 or 100%. So the whole thing has to add up to 1, all right? Which brings us to this other, actually one of the last topics, the last topic of this section that I'm going to give an example for, the complement of an event. The complement of event A equals A with this little c that they have for an exponent. This is the event, or this is the event that A does not occur, A complement. So if you take the probability of A plus the probability of A complement, they have to add up to 1. Which means if you subtract the probability of A complement from both sides of the equal sign, you have that the probability of A equals 1 minus the probability of A complement. And you're going to run into this later to where it's going to be easier to calculate probabilities using complements than it is directly. So for example, you draw a card from a standard deck of playing cards. What's the probability it's not the King of Hearts? That's going to be 1 minus the probability that it is the King of Hearts, or 1 minus 1 over 52, or 51 over 52. So sometimes if you do it directly, the probability not the King of Hearts, that's going to be 51 other things that you have to go through if you're trying to do it directly as opposed to using complements of an event. Look over the probability related to statistics on pages 150 and 151, and then look over whatever examples and guided exercises in the section that you want to or think that you need to go back and look at before you take your test. Here's recommended homework 7, 11, 17, and 19, and don't forget you have tabs underneath of those to where you can work on it and press the tab and see the answer, or you could just press on the tab and see the answer and how they got it.